Alright, today we are learning section 6.6, rational numbers. Everybody should be on page 283. Page 283 in your books. Alright, so in example 1, we need to be able to identify whether the number is rational and, more importantly, write it in A over B form. Okay? Well, what is A over B? What do I call that? I call it a fraction, right? So I need to be able to write these numbers in a fraction in order to show that it's rational. So in number 1, I have 6. Well, to write 6 as a fraction, how would I write it? 6 over 1. So now I have shown that it's rational. 6 equals 6 over 1, and that's my answer. Now number 2 is tricky because it's already a fraction, right? It's already in A over B form. But the problem is that the negative is not attached to any number. So, in order to write this one as a rational number, I have to either attach the negative to my numerator or attach it to my denominator. Either one is an acceptable answer, but you must attach that negative. So, either one of these would be the correct answer. All right, now number 3. How do you think I could write 0.6 or 6/10 as a rational number? How do you think you could write it, Kevin?
I was going to say your screen's not on.
Oh, thank you. How would I write that as a rational number? How do you think? 6/10. How could you write it as a rational number? How could you write it as a fraction? Justin? 6 over 10. Now, in this case, I do not want to reduce it because it will change the value. I want to be able to go back and forth between the original and the way that I wrote it rationally, so you do not want to reduce these. Okay? Now, number 4 is kind of tricky because I have a mixed number. So how could I write this number in A over B form, do you think? How could I write this number in A over B form? Any ideas? McKee?
You can make it negative 14.5.
Perfect. Very good. You could change it to an improper fraction, and you can make it negative 14 over 5. Is there another acceptable answer, Hazen? 14 over negative 5. As long as the negative is attached to the numerator or denominator, it is written rationally. Okay? Any questions about writing a number in rational form? A over B form. Any questions? Okay, now let's talk about ordering them. Ordering rational numbers. Now, your book tells you to use a number line. You can absolutely use a number line, and we will do that on the first one. But you may need to do a little bit of converting as well. If there's a number, not much, okay, if there's a number, now sometimes you can just look at these and they're far enough apart in value that you can just graph them and you know which one's lower than the other one. But in this case, you have negative 5/8 and negative 0.8. It's hard to tell which one's smaller. Can you tell me with 100% certainty which one is smaller than the other one? No, you can't. So how could you, what's one way that you could figure this out? Do you know, Hazen?
You can find the common denominator.
Well, one's a decimal, one's a fraction.
Yeah, but you turn it into the fraction then.
Very good. You turn it into a fraction. You could do that, but then they wouldn't have the same denominator. You'd have to find a common denominator. Or you could change negative 5/8 into a decimal. All right, so just do 5 divided by 8 in your calculator, and you get negative 0.625. Okay, and now you can easily order them. It would be, what would be the smallest number here? No, what is the smallest number? It's going to be negative. Negative 1. Negative 1. The farther away from 0 it is, the lesser the value. All right, what's the next smallest number? Negative 0.8. negative 5/8, because I know that's 6.625, which is going to be a little bit bigger, and then 2.5. So I just order them least to greatest. Now, if they wanted you to do it on a number line, I don't believe your homework asks you to do this, but it may be easier for some of you to graph it on a number line. Okay, we're just going to simply plot these values, and it honestly doesn't even matter what order you do it in, but we'll just go left to right. 4 1/5. Where is that one going to go? It's going to go way up here, just above the 4, right? And I would label it 4 1/5. Then I have negative 3.6. So where is that point going to go on the number line? Where is it going to go? Right in between what two numbers? Negative 3 and negative 4. Pretty much right in the middle, because negative 3.6 is pretty close to negative to 3.5. Okay. What about negative 3 8/9? Where would that one go? No. Negative 3 8/9, that's pretty close to 4, right? I mean, all you need is one more ninth, and it would be 4. So it's going to be like right next to the 4. Not on it, but right next to it. And you would label it negative 3 8/9. Okay? If you need to, you could point an arrow to it. And then, last but not least, you have 0. So you'd plot it on the 0. Okay, and that's how you would graph it on a number line. Now, like I said, your homework doesn't ask you to do it on a number line, but it might be easier for you to tell which one's, a lower value than the other one. All right, moving on to your properties, okay? With the commutative properties, and you do need to jot down these definitions. You will need to know them frontwards and backwards.
Please pardon the interruption.
All right, commutative properties, and I've highlighted in red the key word here. Commutative property of addition says that you can add numbers in any order. For example, 4 plus 3 equals 7, and 3 plus 4 equals 7. They both will come up with the same answer, even though you're adding them in different orders. Same thing with commutative property of multiplication. 3 times 4 is 12. And 4 times 3 is 12. You can multiply the numbers in any order. So the key word here is order. Commutative property deals with the ordering of the numbers. Sometimes it's beneficial for me to change the order of the numbers, especially when I'm adding negative numbers, and you'll see that in a second. All right, moving on to the associative properties. Associative property. Now, guys, remember, don't write every single word. Associative property of addition, so you could label, or you could abbreviate addition, just add. All right, you don't have to write out the whole word. Associative property of addition says that you can change the grouping of terms and it doesn't change the answer. 3 plus 4 is 7. You always do what's in parentheses first. 7 plus 5 is 12. Or 4 plus 5 is 9. And 3 plus 9 is 12. So you can change the grouping and it doesn't change the answer. Same thing with multiplication. Change the grouping, it doesn't change the answer. 12 times 5 is 60, or 4 times 5 is 20, and 20 times 3 is 60. And this works 100% of the time, okay? Changing the grouping of numbers whenever you're multiplying does not change the answer. Now we have the inverse properties. The inverse properties. The key word here that you need to remember is opposite. So the inverse property of addition states that you take a number, you add its opposite, and you will always get 0. 7 plus negative 7 is 0. 5 plus negative 5 is 0. 3 plus negative 3 is 0. Take a number, add its opposite, and you will always get 0. The inverse property of multiplication says, take a number, multiply its reciprocal, and you always get 1. 9/20 times 20 over 9, they cross reduce, and you get 1. 3/4 times 4/3, and guess what? They cross reduce to 1, and your answer is 1. Okay? So anytime you take a number and multiply it by its reciprocal, you will always get 1. That's your inverse property of multiplication. Take a number, multiply by its reciprocal, and you will always get 1. Now, lastly, we're going to talk about the identity properties. Here, the key word is mirror, because the identity property of addition states that anytime you take a number and you add 0 to it, it will be the number itself. Negative 7 plus 0 is negative 7. 5 plus 0 is 5. 10 plus 0 is 10. 12 plus 0 is 12. So anytime you take a number and you add 0 to it, the answer is the number itself. The identity property of multiplication states that anytime you take a number and you multiply it by 1, it will be the number itself. 9 times 1 is 9. 5 times 1 is 5. 2 times 1 is 2. 20 times 1 is 20. Okay, so take a number, multiply it by 1, and it will be the number itself. Those are your identity properties. Okay, so just as a quick review, here's the key words that you need to remember. You don't necessarily have to write this part down. You probably already have written it down in your notes already. Commutative property deals with the order. Associative property deals with grouping. Inverse property deals with
Opposites.
and identity property deals with mirror. Okay, so those are my key words for my properties that will help me remember which property I'm looking at. All right. What if I gave you 12 minus 4 plus 15 minus 5? What property would be helpful here to use in solving this? Assuming I can't use a calculator, what property would be helpful to use? What property would be helpful to use? Not necessarily associative, because it doesn't really matter that in that case. Zach? The commutative property. If I'm going to use the commutative property, how would I want to rearrange this? Chris?
Put all the negatives together and all the
Very good. Group my positives and group my negatives together. And now 12 plus 15 is 27, and negative 4 minus 5 is negative 9, and I should get 18 for my answer. Okay? So you see how the commutative property of addition helped me here, because it says I can reorder them. I can write my numbers in any order and still get the same answer. What if I had a problem like this? 94 plus 87 plus negative 94. All right. What property could I use here that would help me? What property could I use here? Hazen? No. Associative only deals with whenever I have an operation within my parentheses. What property? Justin?
I was about to say inverse.
Not yet. Well, no, you could. Well, we need one step before that. Hazen? Nope. Commutative. Why would I want to rearrange these numbers, and how would I want to rearrange them? Okay, very good. I want to put negative 94 right next to positive 94 because I'm solving left to right. Okay, that's commutative property. Okay, now I'm gonna write it one more time. Now what property could I apply to make this a little bit easier? What's the property where you can add the opposite and it's always 0? It's the, not identity, opposite. The inverse property of addition says I add the opposite, it equals 0. So that's the inverse property of addition. And what property states that I can add 0 to any number and it will be the number itself? The identity property. See the steps? Okay, and then 87 would be my answer. All right, and generally, if you understand that, that's everything you need to know for 6.6. Obviously, this is a lesson that is going to require a lot of practice. Okay, so the more you practice, the better you'll understand this.